Bismillahirrahmanirrahim, one of the most successful scientific theories in history. It could easily be called the most groundbreaking achievements of the 20th century. So much so that 1/3 or even more of our economy today runs on it. I'm talking about quantum mechanics, or the study of the very small. So the atom, the electron, the proton, the quark, the basic building blocks of the universe. This theory is such that it does not even have a competitor when it comes to being verified both experimentally with observation. The mathematics works. I'm going to use it. I'm going to use quantum mechanics today to prove the existence of God. Okay, despite the fact that quantum physics is so successful, it really has some very controversial, very counterintuitive things to say about the nature of the universe. For the present discussion, I'm just going to take one, and that is that quantum physics actually hints that the fundamental nature of reality of the universe is not even physical. Take that. Okay. Not even that. It brings something so non-physical, non-material, lifelike, like consciousness, into the realm of physics. So let's get that straight. If we want to speak about the natural world, we want to study the natural world, we go into biology, we go into, life sciences, geology, and all of that. But if we want to go a bit deeper and study the chemical composition of stuff, then it's chemistry. If we want to go further deep and study the universe at its core, fundamental, elementary level, we go into quantum physics. So when we are saying that we have encountered consciousness, it's not from neuroscience or biology or life sciences. It's from the bedrock of science, from the foundation on which everything is built.
I'm going to demonstrate the results of this amazing experiment with a bunch of baseballs and a barrier that we've set up which has 2 holes in it. Now, normally in the everyday world, if I throw baseballs through one hole or the other, they'll form a predictable pattern on a screen that we've set up behind home plate. They'll be in one place or the other. Now, let's make that pattern with a whole bunch of baseballs. I'm going to use this pitching machine. Here's the first one. Let's see what happens. Now you see, the balls landed on the screen in 2 bunches, pretty much along a direct line from each of the 2 holes. That's natural. That's what we expect. But when we descend into the microscopic universe and use electrons, which are 10 trillion times smaller than baseballs, we get a very different, odd result when we perform this experiment. A pattern that you would expect if these were waves going through both holes at the same time and interfering with themselves. Well, we usually think of electrons as being particles, so how can they exhibit wave-like properties?
These test results were confounding. The electron was a particle before it was fired at the screen, yet it formed a pattern on the screen, as if this single electron had gone through both holes at the same time. Does a microscopic particle spontaneously clone itself in midair? After years of study, scientists still don't know exactly what's happening.
Probably the most magical thing is that in quantum physics, an object can be in more than one place at the same time.
It actually can sense both slits and actually go through and quantum mechanically feel the structure of both slits in the experiment.
Most physicists agree that the math is quite solid and leads to solutions that are undeniable and can be confirmed with experimental measurements. But exactly what is happening and how is a matter of debate.
To try to grasp this amazing experimental result, scientists decided to observe how individual electrons behaved when they went through the double slit. How exactly could a particle go through both holes at the same time?
Scientists got a front row seat to observe the strange behavior of these electrons or other subatomic particles or even photons of light. Doesn't really matter as long as they're small. They didn't just look at where they landed on the screen back there. They also watched the behavior of the particles as they went through the holes. And then they saw something amazing. When scientists were watching the holes, the electrons behaved like particles, forming the baseball-like pattern on the screen back there. But when the scientists weren't watching, then the electrons behaved like waves. They formed a pattern that looked like the interference pattern produced by waves on a screen. That's really strange. What you see depends on whether you're watching or not. If you're watching, you see the particle-like behavior, like baseballs. If you're not watching, you see a wave-like behavior, but not both at the same time.
This was nothing less than astounding. Observation seems to change the nature of subatomic particles.
Mysteriously, when we're not looking, things are waves. When we are looking, they look like particles. So even an electron, which seems to us like a particle, has wave-like properties when we're not looking at it.
The fact that when we don't look, the electron appears to go through both holes, but when we do look, we always see it go through one hole or the other, is what we call the quantum enigma.
How could our decision about whether to observe something change how that something acts? There is a technical explanation.
To make an observation, you somehow have to interact with the system. For example, you have to shine light on it, which then bounces off and you observe the light. That's how we can tell that a baseball is here or there. We bounce light off of it. Well, for macroscopic particles, that doesn't disturb them very much. But for microscopic particles, the act of bouncing the light off of the particle changes where it is and how it's moving.
So in the microscopic universe, where photons of light are about the same size as subatomic particles, these photons have a big impact when they illuminate the particles so we can see them. But this doesn't answer the question. Why doesn't the light simply change the direction of the subatomic particles? Why does observation actually change the nature of what is being observed?
The short answer is we don't know. This is the fundamental mystery of quantum mechanics, the reason why quantum mechanics is difficult. Mysteriously, when we look at things, we see particles. That when we're not looking, things are waves.
This is something we scientists have argued passionately about now for almost 100 years, and there's still no consensus.
When they were first released a century ago, these test results were enough to unsettle the brightest mind in science.
Einstein said, "I don't believe in quantum physics because I believe the moon is there even when I'm not looking at it." Einstein was, of course, referring to the implications of the theory that the moon really isn't anywhere until it's observed.
Okay, just to summarize, the double slit experiment, all it tells us is that reality, the universe at its core fundamental level, at the quantum level, is not just something, solid, physical, no, and deterministic, no. It exists as a wave of probabilities, as a wave of possibilities. Two is somehow our conscious observation, our consciousness affects it. That's even weirder. What has our consciousness got to do with the world that makes up everything, the basic building blocks of nature? But it was still so counterintuitive that Einstein didn't really like it, and he would say that I do not like quantum mechanics because God does not play dice. In the sense, what he meant was that the reality at its fundamental nature cannot be probabilistic, because dice is probabilistic, to which Niels Bohr, the founding father of quantum mechanics, would remark that Einstein should stop telling God what to do.
The most successful physical theory of all time is called quantum mechanics, the theory of the atom, because it's based on the idea of probabilities, that you don't really know where an electron is, and electrons can exist in some sense in multiple states at the same time.
Erwin Schrödinger, one of the founders of quantum mechanics, designed a thought experiment to drive home the strange rules of his theory. Let's say we put a cat and a vial of poison in a box. We add an atom of radioactive uranium and a Geiger counter. If the uranium decays, it sets off the Geiger counter, which then releases the poison and silently kills the cat. Before we open the box and look, we can't actually know whether the uranium has decayed or not, since radioactive decay is a probabilistic quantum event.
Here's the question. Is the cat dead or alive? Well, according to quantum mechanics, the cat is neither dead nor alive, but the sum of the two states. Well, at that point, you say, well, that's nonsense. That's preposterous. How can you be both dead and alive simultaneously?
Schrödinger's cat was supposed to show that nothing in this universe is certain until someone makes a measurement. But another pioneer of quantum mechanics, Eugene Wigner, believed it could teach us something else about the working of the universe, that consciousness controls everything.
Wigner said, let's take it one step farther. If I, a human being, looks at the cat, I am conscious. Therefore, consciousness determines existence. At that point, Einstein went ballistic and said, what? You're saying that the fact that you are a conscious being determines the fact that the cat is alive? Answer is yes. And Wigner made one more step, and that is, how do I know I'm alive? You see, the cat and me, we're part of the same universe. If I don't know the cat is alive or dead, I could also be dead at the same time and not even know it. So who determines that I'm alive? Well, Wigner's friend looks at me, I look at the cat, and we exist. But then who looks at Wigner's friend? And there's an infinite chain of people looking at people, looking at people, until finally you hit cosmic consciousness. Some consciousness that's ethereal, that envelops the universe, which looks at us and says, aha, the cat is alive.
Wigner believed that consciousness is an inextricable part of reality, that nothing really happens in the physical world unless a conscious mind observes it.
The observer effect of quantum mechanics happens when observation or measurement changes the nature of a quantum particle. From a probability wave, which is an unreal thing, to a real thing. This is by far one of the biggest controversy and achievement of the modern world. Controversy for atheism that has pervaded our scientific circles, and achievement for theistic traditions, especially Islam. Why do I say Islam? Because the observer effect of quantum physics was already predicted by the Quran 1.5 millennium ago. Immediately after the weird behavior of quantum particles was discovered, the next question that was asked by the founders of quantum theory was, life is also made up of atoms, so does life also behave in this controversial manner? Listen to these words carefully. سنريهم آياتنا في الآفاق وفي أنفسهم حتى يتبين لهم أنه الحق أولم يكف بربك أنه على كل شيء شهيد. In future, we will show them our signs in the universe and within their own selves, their consciousness or their physiology, until it will become clear to them that He is the truth, the real, annahul haq. Is it not enough for them to know about your Lord, that it is He who is observant over everything? Ala kulli shay'in shaheed. What is interesting about this verse is that firstly it anticipates future discoveries in astronomy and cosmology, fil afaq, and these discoveries will also extend to human consciousness and physiology, wa fi anfusihim, something which is common to both microscopic and macroscopic worlds. Nothing other than quantum mechanics fits this description, especially because the central theme of quantum mechanics is that the world around us, including us, is not physically, objectively real. The verse then says the consequence of these new developments in cosmology and physiology would be to necessarily conclude, the existence of an all-observing intelligent being, annahu ala kulli shay'in shaheed, who represents the only objective reality. Since everything else is not objectively, physically real, the only objective reality would be this all-observing intelligent being, annahul haq, apart from whom nothing else can be called real. The most important point to understand by any serious student of science is that the observer effect is not just an anomaly or a counterintuitive mishap that just happened in one experiment. The observer effect is a meta-phenomenon. It presides over all processes, equally valid to all pure state quantum events. It is a fundamental quality of the quantum world that makes up everything in the universe, that it is sensitive to conscious observation. This is not just an accident, rather a basic mechanism of how the universe functions at its fundamental level. So whenever we hear the phrase a pure quantum event, we must know with surety that conscious observation will affect it. Understand is that the quantum world is not only affected by our observation, the quantum world does not have any physical existence. It does not exist in our three-dimensional universe. It is our conscious observation that makes it real. Something that occupies space has properties. Until then, it is just a wave of probabilities, not a wave of energy or matter, a mathematical wave or a collection of all the possibilities that the particle has. And when we observe it, it takes up one or the other of its possibilities. So if the universe at its core has no physical reality and it is our conscious observation that makes it real, then what is the necessary conclusion that we are left with? It is that the conscious observation or consciousness is the most fundamental thing to the universe. It's not matter, it's not space or time. All are emergent. The most fundamental thing to the universe is consciousness. When we have completely absorbed these 2 points, that the quantum world is an unsettled collection of possibilities, and it is our conscious observation that gives it reality, then we very well know that there are quantum events going on in the universe at each and every fraction of a second. We occupy a very insignificant portion of the vast expanding universe. We have to understand that when we look around the world, we see a real three-dimensional physical universe. We don't see any fuzzy wave of probability. From the deep recesses of the planet, ocean beds, uninhabited forests, islands, think about the solar system, the Milky Way, the cores of stars where all the elements that we are made up of are manufactured. That's carbon, oxygen, calcium, iron. Also, violent explosions of stars or supernovae that produce all the heavy elements that we see around us. Okay, what about the horizons of black holes, in the cells of plants, in the eyes of birds, in the fertilization of an embryo, in the germination of seeds, in the growth of a human being, inside the brains of living beings, in the evolutionary process at the beginning of everything, at the beginning of the universe itself. Quantum mechanics lies at the root of all of these phenomena. I ask you, what is this consciousness that is present everywhere in the universe, from the beginning of time till the end of the universe, and everywhere in between, observing everything in such a subtle manner at the fundamental level of existence? Again, I say the observer effect is a meta-phenomenon. It is not just an anomaly that can be easily ignored or left for philosophers to discuss or undermine by suggesting other highly deterministic and philosophical interpretations. The observer effect is here to stay, and the most scientific thing to do is to deal with it. It is as applicable in the double-slit experiment as it is in nuclear reaction in stars, in the retina of birds, in the photosynthesis of plants, in the formation of a human being in the uterus, in cell division, in the evolutionary process, at the beginning of the universe. The beginning of the universe is actually a quantum event, a pure state quantum event. The universe as a whole has a universal wave function, that is, a collection of all possibilities it could potentially realize. But when we look around, we don't see the wave function. We see a real three-dimensional universe. Why? Because there is someone observing the entire universe from the beginning to the end. This is the absolute consciousness. Here is science itself proving the existence of a conscious, intelligent being who is ever present and ever observant of each and everything that is happening in the entire universe.